students, today we'll start chapter number 3, Current Electricity, a very important chapter with different laws and different devices. Now before starting this chapter, Current Electricity, just I will introduce you some very important thing, and that is that now the charges are in motion. When the charges are in motion, they constitute an electric current. If I say charges are now not in rest, charges are in motion, okay, then they will form what? Electric current. That's also known as electrodynamics. Electrodynamics, okay. Now, if I talk about the charges in motion, one of the example in electrostatic is lightning. Now, when the lightning takes place, charges flow from the clouds to the earth, okay. But then the flow of the charges of lightning is not steady. That when the lightning takes place, are you getting it? The flow of charges from clouds is not what? Steady. So what we need? We need a steady flow of charges. We need a steady current. So when we talk about the steady current, you need a continuous flow of what? A constant current. That can flow like the water flows smoothly in a river. Okay, the charges should flow smoothly. And for that, you need what? A constant current, a steady current. And for that, a torch or a cell or a battery can work with certain laws. Now for that only, I have just a very simple thing I want to show you is that this is a what? Two batteries of 1.5 volt. And I know that this is a positive end, this is the negative end. And when I touch it with the bulb here, so what I see is that this is the positive end, okay, and this is the negative end. So if I touch it here, the bulb glows. Are you getting it? Now this current is a steady current. This is a constant current. So we need certain laws that follows this constant current, the battery, the resistance, the wire, the bulb, and certainly we need an electric current. So this is how even we can show it in the LED also. This is the way we can represent. So it's a constant current. So this is how we have applied a battery potential difference, a constant current flows. Now what does it mean by what? Electric current. The second thing comes is that what exactly is electric current? Now electric current is actually, we say that a rate of flow of charges. Okay. So when we talk about the rate of flow of charges, that is known as what? Electric current. And electric current is simply represented by what? I. And I is what? Q by T. What is Q? It is charge. What is T? It is time. So certainly it is what? 1 ampere is equal to 1 coulomb by 1 second. What is the SI unit of current? Is what? Ampere. So we know that 1 ampere is 1 coulomb per second, and the net amount of charge flowing across the area in forward direction in time t. This is the net amount of charge and it is flowing in time t. That forms what? A steady current. Okay. Now that current which is flowing through the circuit is passing through a conductor. So in current, say if delta Q charges pass in delta t time, so that means we can even define for that time current as limit, are you getting it or not, delta t tends to 0 that is delta Q by delta T. So this is also a rate of flow of charge. So this is another form of current. That means I can write current as what? dQ by dt. This is current. Got it? So rate of flow of charges, and I is Q by T. We can write I dQ by dt. Say for example, when I is dQ by dt, the question is given if the charge flowing in a circuit as function of time, are you getting? And it is given by Q is equal to 3t square plus 2t plus 1. Find current at t equal to 1 second. Now very simple, I is what? dQ by dt. So you will integrate, differentiate it, 3t square plus 2t plus 1, and if you solve it, I'm going to write it, it will be 60 plus 2. Okay, so 6 into time is 1 plus 2, that is 8 ampere is the current. So such type of 1 mark question can be asked in the paper. So this is how we can find out, as charge is function of time, we can find out the current in the circuit. And it can be in the reverse way also. Sometime you know that you will be given that if the current in a wire is given by, okay, I equal to t square plus 1, then find the amount of charge flowing from 0 to 2 seconds. So the very simple, we know that I is what? dQ by dt. Are you getting it? It is again the differential, so dQ will be what? I dt. All of you know what will be Q? It will be I dt, integration from 0 to 2. You will put it what? The value of I. What is I? T square plus 1 dt. So if you solve it, the integration it will be, I am going to write it, it will be tq by 3 plus what? T, 0 to 2. So final answer is upper limit minus lower limit 2q by 3 plus 2, and it will be minus. So it will be 8 by 3 plus 2, that is 14 by 3 coulomb. Are you getting it or not? So I is dq by dt, dq is equal to I dt, q is integration, you put it here, it will be tq by 3 plus t, and then you solve it out. It is going to be what? 8 by 3 plus 2, 14 by 3 coulomb. So these type of questions can also be asked. So this is how we have started with current in a conductor. Now further we will move and we'll talk about how the electric current comes in the conductor. So electric current in conductors. Electric currents in conductors. See, generally conductors develop electric current in them when electric field is applied. Conductors, you know that they have free electrons, so conductors, they develop current, okay, when electric field is applied. When electric field is applied. So this is a very important thing if you apply an electric field. Say I am just saying you that there is a conductor. If I take a conductor and there is a conductor light right now, this one. Okay. Now right now at room temperature, you know that the electrons will have what? Thermal velocity. Those charges, electrons, will have what? Thermal velocity. Now, do you know the average thermal velocity of electron is 0? Why? Because there is a random motion. Because of the random motion, randomness, the average value is 0, because whatever the direction will be in the forward, that will be in the backward due to the temperature. So there is a collision, and that will have what? Average thermal velocity of electron 0. There is no electric field. Now if I apply, say, if I put one end at positive charge, are you getting it? And the another end at negative charge. Here it is plus Q, here it is minus Q. Do you know what will happen? An electric field will develop inside it. And because of this positive, this electron, these negative will flow. Are you getting it? We have applied plus Q and minus Q here. The electron will flow. So electron will flow, and we can say electron will drift. There is a very important word. Drift towards what? Positive end. And that will constitute what? In a electric current. So this way the electric current develops. Are you getting it? Now it will be for a short time. If you want a continuous current, you need to apply some source. You want a continuous current, you need to apply some source, like you need to apply some source, that means like a battery. You need to apply a battery across it, so that from this end to this end there will be a continuous flow of what? Electron. So they will move like this. So in this way the electron will move in this direction, whereas the current moves just opposite to, because this is the drift opposite to electric field. Electric field is in this direction. So this is how the current forms, and that is how we show that this is the battery potential, and this forms what? A steady current. We have taken a steady. So I gave you an example. I gave you how the bulb glows for a steady current. If you see that bulb is not fluctuating, it is with a steady current. This is what? Now there comes what? Very important word, drift. And what is drift? This is a drift velocity. Are you getting it? Electron is moving from what? Negative end to the positive end. And what is the drift velocity? Drift velocity is very, very important. You know that it is actually the average velocity. I'm writing the definition. The average velocity, it is the average velocity, that is the average velocity is the average velocity due to free electrons moving from what? Moving from negative and to positive end of conductor. And do you know of conductor in which direction? In the opposite direction of what? Electric field. In the opposite direction of electric field, that is applied electric field, we can write it. So this is the definition. This is actually a drift velocity, very important, denoted by Vd, and this will be the velocity when it will go from negative end to the positive end. So this is how we have started with the drift velocity. The first concept which comes is the drift. Now expression for drift velocity. How we are going to derive the expression? See, drift velocity is the average velocity of the electrons. You know that. And the expression of drift velocity is minus E by m into tau. This is the expression. If you ask me what are these values, I will tell you Vd is what? Drift velocity. Okay. What is E? Charge of electron, electron charge, charge of electron, and then capital E, you know, it is electric field, and here this tau is actually the time, the relaxation time, relaxation time, and then m is the mass of electron. So this mass of electron. So this is the expression we are going to get from the drift velocity. Now already I have explained you, if there is a conductor and there is a conductor where there is no electric field is zero. So the average, the average random thermal velocity is zero. Already I have explained it. It will be zero. Do you know? Because the collisions inside the conductor due to the thermal velocity will make it zero. So say consider that let u1, u2, u3, like we have initial velocity dash dash un be the thermal velocities. They are the thermal velocities of what? Electron. So we know that their average will come what? The average of this value will be what? Zero. So we need what? Electric field to move electron. Okay. So now we need an electric field. So again I will take the conductor, and we know that this time the conductor, it has a positive charge at this end and it has a negative charge in this end. So what will happen? An electric field will be there, and this electric field is from what? Positive to negative. And if you want a constant electric field, will apply with the source also. So what will happen? The electron will start drifting. So electron starts what? Accelerating. Electron starts accelerating from what? Negative end to what? Positive end. Got it? So if they start moving on this side, there will be a force due to the electric field in the opposite. And all of you know what is force? QE. So we will have what? Minus EE, because this is the electron charge. And what is force? Mass into acceleration. So minus EE. So can we get the acceleration for the electron? Yes, minus EE by m. This is the acceleration of electron. So we got the acceleration, and the electron will drift from this side. So now the velocities of electron will change. Now the velocities of electron, like we have final velocities. So velocity of what? Electrons will be what? V1 is equal to U plus AT, U1 plus A, tau 1, V2 is equal to what? U2 plus A, tau 2. In this way carry on, V2, V3 is equal to U3. For n electrons we are taking, because the number of electron dash dash, we have Vn is equal to Un plus A tau n. So these will be the final velocities of the electron, and average of this final is known as what? Drift velocity. We know Vd is what? V1 plus V2 plus V3 plus dash 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 Vn by what? N. So this is the thermal velocity. We are going to put the values here. If I put U1 plus what? A tau 1, are you getting U2 plus A tau 2, okay, and plus U3 plus A tau 3. It will go on like this, Un plus what? A tau n by what? N. And then what you do, that you take U1 plus U2 plus U3, are you getting it? Plus dash 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 Un by n in one bracket, and another A will come out, and it will be tau 1 plus tau 2 plus tau 3 plus dash 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 tau n by what? N. And this is 0, because already we have explained the average. So it will be what? A what? And this will become tau. So Vd is what? A tau. Got it? This is Vd. What is tau here? Tau is actually the average relaxation time. Average relaxation time. Okay, that is average time between two successive collisions. So that is relaxation time. And finally, if I replace acceleration from here, so Vd becomes what? Minus EE by m into tau. So this is the final expression which we get by putting the value of what? A. So we have put A here. So this is the expression. So how we got the drift velocity? Are you getting it? So this is the force, and then this is the acceleration, then there is velocity, and then drift velocity is the average, and this is the final expression for the drift velocity of electron. Very important part, how we get drift velocity minus E by m into tau. So this is drift velocity. Vd is equal to minus E by m into tau. Are you getting it? So here we see that Vd is what? Opposite to minus E. That means drift velocity is what? Opposite to electric field. This is the significance, opposite to electric field. And in numerical, generally we can take mod also. We know that E by m into tau. This we can use in numericals also. This is how the drift velocity comes. Okay, and there's a question that if the voltage across conductor is same and length is doubled, so what will be change in drift velocity, or what will be the new drift velocity? We can say like this, 1 mark question. So very simple. What is Vd? E by m into tau. How many of you know that electric field potential difference is E into L, electric field into length? So can we put E by m into tau as what? E, in place of E we will put V by L, so ml into tau. So that means, are you getting it? In place of E we have put V by L. So Vd is inversely proportional to length. So if length is doubled, drift velocity will be what? Half. And if length is halved, drift velocity will be what? Doubled. So this type of question can be asked in the exam. So this is how we can explain the drift velocity. If the voltage across conductor is same and length is doubled, so what will be the change in drift velocity? V is EL. Vd will be this, E by m. We can replace by ml into tau, and Vd is inversely proportional, length double, Vd halved. And if it is given that length is halved, what will happen to the Vd? It will be doubled. So this is how we can go through the concepts in drift velocity. So today we have discussed the current, the introduction, the chapter, how the current came, what is the role of electric field, how the drift velocity existed. Okay, thank you, and regularly watch my videos.